Electricity costs keep rising, but most people never question how efficiently they are actually using power inside their homes. The surprising truth is that a large portion of household energy is not used effectively. Some of it is wasted through inefficient devices, some through heat loss, and some through the way electricity is converted and distributed inside everyday appliances. This means that reducing a power bill is not always about using less electricity. Sometimes it is about using electricity more intelligently. One category of devices focuses exactly on that idea. Instead of trying to generate huge amounts of new energy, these systems focus on improving efficiency, reducing losses, and managing how electricity flows through a home. Understanding how these devices work starts with a simple observation. Most homes draw electricity from the power grid in a constant stream. Power flows into the house, spreads through the wiring system, and is consumed by dozens of devices throughout the day. Lights, refrigerators, air conditioning units, chargers, televisions, and kitchen appliances all draw power in different ways, but not all electrical devices use energy in the same manner. Some appliances operate smoothly with a steady electrical demand. Others pull bursts of energy when motors start or compressors activate. These rapid changes in demand create fluctuations in the electrical system inside the home. When motors start suddenly, they often draw significantly more electricity than they use during normal operation. Air conditioners, refrigerators, and pumps are common examples. Over time, these repeated energy spikes increase the total amount of electricity drawn from the grid. This is where certain power management devices attempt to improve efficiency. One type of device focuses on stabilizing the electrical flow entering a building. These systems are sometimes described as power factor correction devices or energy optimization units. Their role is not to produce electricity but to manage how it is delivered and used. Inside many electrical systems, voltage and current do not always move perfectly together. When motors and inductive loads operate, they can create small delays between voltage and current. This condition is known as a reduced power factor. In large industrial facilities, correcting power factor is a common engineering practice. Capacitors are used to help align the electrical phases more efficiently. This reduces unnecessary reactive power flowing through the system. Some residential energy devices attempt to apply similar concepts on a smaller scale. They typically include capacitor networks and basic control circuits designed to smooth electrical fluctuations. By stabilizing voltage and reducing some reactive losses, the electrical system can operate more efficiently. Another approach focuses on reducing transient spikes. When large appliances turn on, they sometimes create sudden surges of electrical demand. Power conditioning circuits can absorb part of these spikes and release energy more gradually. This helps reduce stress on wiring and electrical components. In some cases, this smoothing effect may slightly reduce overall energy consumption. However, it is important to understand the realistic role of these devices. They do not create energy, they do not eliminate electricity usage, and they cannot replace the power drawn by major appliances. Instead, they work by improving how electricity moves through the system. In the best scenarios, efficiency improvements can occur in specific situations where inductive loads are common. For example, homes with several motors or compressors may benefit from more stable electrical flow. This includes homes with large air conditioning systems, water pumps, or workshop equipment. Even then, the level of improvement varies. Energy savings usually depend on how much reactive power exists in the system and how effectively it can be corrected. Another important factor is general efficiency habits. Devices that manage electrical flow work best when combined with practical energy awareness. Replacing older appliances with efficient models, improving insulation, and reducing unnecessary standby loads often produce larger energy savings than any single device alone. Still, power optimization technology illustrates an interesting idea. Electricity systems are not only about generation, they are also about management. The way energy flows through a system can influence how efficiently that energy is used. This concept is widely applied in industrial engineering. Factories often install power management equipment to maintain stable electrical performance. Data centers and large facilities use advanced monitoring systems to optimize how electricity moves through complex networks of equipment. In residential environments, the same principles can sometimes be applied on a smaller scale. Understanding how energy moves through a home provides a clearer view of where electricity is actually going. Many people assume that electricity usage is simply the result of appliances turning on and off. But the electrical characteristics of those appliances also matter. Voltage stability, phase alignment, and load behavior all influence how energy moves through the system. The key insight is that improving efficiency often begins with understanding the system itself. Instead of thinking about electricity only as something consumed, it helps to think about how it flows. Once that perspective changes, it becomes easier to see where improvements can be made. Sometimes those improvements come from better appliances, sometimes from better insulation, and sometimes from devices designed to stabilize the electrical environment inside a home. Each improvement contributes a small part to the overall efficiency of the system, and when several improvements work together, the difference in energy consumption can become significant. The goal is not to rely on a single miracle solution. The goal is to build a smarter energy system inside the home. One where electricity moves efficiently and devices operate under stable conditions. This is the same philosophy used by engineers who design modern electrical infrastructure. They focus on reducing losses, improving stability, and optimizing how energy is delivered. Small improvements across a system often produce meaningful long-term results. If you enjoy learning how everyday electrical systems work and how practical technologies can improve energy efficiency, consider subscribing to the channel. New videos explore real engineering concepts in clear, simple terms. You can also check the description for a helpful resource that explains some of the components commonly discussed when people study small-scale power optimization and home energy systems.